Now we're talking a bit about compilers and the fact that often compiler writers, the writers of these translation programs, from high-level English-like phrases to low-level, very low-level machine code of basically binary strings, zeros and ones, they will often start with a grammar, and they can then use that grammar to help them write the compiler. For example, often part of the compiler, an important component of the compiler, is called a parser. To parse in ordinary English usually means to break down a sentence into its parts. For example, keep it simple, like you take a sentence like Tom kicked the dog. So you'd have a noun, the subject would be Tom, the verb kicked, and the object dog. Okay. So parsing that sentence into a noun, a verb and an object. Simple. So to parse a statement in a computer language is to break it down into its components. So the parser, in a sense, can extract some of the meaning of the program, what the program's trying to do, and then it compiles, performs the translation program from high-level statements to low-level machine code. Right? Now, you can actually create the parser by using the grammar. So the grammar can aid the creation of a parser, which is a very important component of the compiler. Now, this course is not a compiler theory course. That's a fascinating topic. And uses grammars and various other things to understand how a compiler works. And the compiler is an extremely useful device, piece of software. Before compilers came along, programming was just tedious. Okay. All right. Now, there are tools that allow you can generate the parser, you can create the parser automatically from the grammar. You just start with the grammar, that's its input, and the tools, the software tools, will automatically generate the parser for you, which you then incorporate into the compiler, given the grammar. So the grammar is very important. Remember the grammar being the set of rewrite rules. Now, I'll use different terminology when we get into the more formal definition of a grammar, as you'll see soon. All right. Okay. Now, there's a category, like a family of set, if you like, of languages that are recognized by context-free grammars, CFGs, context-free grammars. That set or collection of languages that are recognized by CFGs. Now remember, that'll be a broader, more comprehensive range of languages than the old, from chapter 1, the old regular languages. Right? CFGs, context-free grammars, allow a broader class or category of languages, more types of languages than just the regular languages. Right? Now that category of languages, they're called CFLs, so context-free languages. Right? So a context-free language is described by a context-free grammar. Okay, so the fact that the context-free languages are a kind of superset of the regular languages, that shows that the CFGs, the context-free grammars, are a more powerful description of languages, category of languages, than are the regular languages. Okay? It's, well, regular expressions, for example. Okay. Now, just a minute. I shouldn't be too long in this session, otherwise I'll run out of memory on the camera. I don't want to have to change it in between sessions. Right. Where were we? Yeah, so in this chapter we'll give a formal definition of what a context-free grammar is. That's not surprising, right? Because we're talking about the whole chapter's context-free languages. So the context-free grammar specifies or describes the context-free language. So we need a formal definition of such a grammar. So okay, and then we'll study the properties of context-free languages. So these two lines are sort of the essence of the whole chapter, right? So very important. Okay, and we'll introduce a new kind of automaton called a push-down automaton. Now, the earlier session I was talking about stacks. So a push-down automaton is an automaton with a stack. So you can push numbers, symbols, whatever, onto the stack and pop them, push and pop them. As I was describing in the previous session. Okay. So a push-down automaton is used to recognize a context-free language. Okay. So that the push-down automaton, or the PA, now before we're talking about FAs, so finite automaton. Now we can talk about a PA, a push-down automaton, and that's an automaton with a stack. Okay? And we'll talk about stacks in detail this chapter, right? These are the kinds of machines that recognize a context-free language. Okay. So if you hear about a push-down automaton, automatically you think, oh, well, it's a machine that is capable of recognizing a context-free language. Okay. All right. And these machines are useful because they help increase level of understanding of context-free grammars. The two sort of help each other in a sense. Okay. Alright, so now we can start the nitty-gritty. So we're now into the first section. All this, these three squares so far, this square and the two from the previous session, we're just sort of lead-in, sort of an overview of the whole chapter. Now we start on the nitty-gritty, the details. So section 2.1. So chapter 2, first section of chapter 2, called context-free grammars. So now we start with a formal definition of what a context-free grammar is. Like these two critical lines, right? In this chapter we give a formal definition of CFGs. Well, here it is, we're starting. Okay. Well, I've already said that in a sort of hand-wavy, vague way that a grammar is sort of a set of rewrite rules. That's just my saying. So now what does Sipser say? That was just before my own, just to give you a taste of what it is. Right. Well, he gives an example, a concrete example of a context-free grammar, and he calls it G1, G for grammar. Our first example, so G1, and here it is. There are three what I've been calling rewrite rules. He calls them substitution rules. Other people, A, K,